Go ahead.
Hello everybody. Before I get started, I just want to know if any of you guys drove to work today or drove to school. So we have a few people that drove to work and a few commuters here, but a lot of us didn't. But I bet that those people that didn't still drove from school or drove from home to get to Mount Union in the first place, or had someone drive us here. So I'm Grant Holcomb. I'm a junior civil engineering student, and I'm going to touch on why driving will be obsolete within our lifetime. So the definition of an autonomous car is, according to Wikipedia, an autonomous car is a vehicle that can guide itself without any human conduction. So I'll get into the practicality of that is there's no brake pedals, there's no steering, there's no manual turn signals. Everything's done by a computer for you. So we're going to touch on the history of the autonomous car. So Digital Trends website shows us that in 1925, the inventor Francis Arduino created the first autonomous car. This was a radio controlled vehicle, so he attached a radio into the vehicle and then was able to control the throttle, the braking, turn signals, and lighting from a remote location while this vehicle drove around. People, however, didn't really believe this happened because, as you can see here, his name is fairly similar to the famous magician Arduino, and they thought this was just his latest trick. Fast forward a few years, 1995, two inventors and researchers, Dan Pomeroy and Holcomb, drove across the USA in a self-driving minivan. So the self-driving minivan, they still had to brake and give throttle and give turn signals, but as far as turning, the vehicle did everything itself. They logged over 2,700 miles in this vehicle. And the next, fast forward a few more years, and then Darga announced its Grand Challenge. Its Grand Challenge was a race across the Mojave Desert. It was a 142-mile course. They did this out in the desert so that if something were to go wrong, no innocent pedestrians would be hurt. But, however, the first winner of the course only made it 8 miles into the race before their car simultaneously combusted and exploded into flames. So, a little more on the history. Self-parking systems came around in the early 2000s, as you guys have probably seen in commercials or maybe even in some of your own vehicles. You can now, the car will parallel park itself. You just pull up, hit a button, and it'll do everything for you. In 2009, Google began developing its first self-driving car. This car still needed an operator. It still had manual turn signals or optional manual turn signal, steering, and braking, but whenever the autopilot was turned on, it did everything itself. It just had someone there to monitor it. So this car drove over 300,000 miles without a wreck. So later, 2014, they released a car without any brake pedal, steering wheel, or anything to that nature. It was fully autonomous, and with this vehicle, they drove over 2 million miles without a wreck. There were still people there monitoring it, but no wrecks whatsoever. But with all this autonomous, eventually there's going to be a fatality. So Tesla had the first fatality in 2018, killing one occupant. A semi or tractor trailer pulled out in front of a Tesla, and the Tesla was not able to sense the truck pulling out, and it struck the semi, killing the occupant inside the Tesla. So where we are right now in other industries. So I grew up on a farm, and I've seen some of this technology firsthand, and even this Case IH, first autonomous tractor. According to the Case IH, the first autonomous tractor came out in 2016. This is very important, especially for the car industry, because the autonomous technology from the agricultural industry will eventually trickle down into the automobile industry. So since the 2000s, even though this is the first autonomous, there's been other auto steer and things like that since the early 2000s. These are able to plant within an inch, which is incredibly important because within an inch in a remote location is very accurate, especially for these farmers who are often out in the hills or in the fields out in the middle of nowhere where cell service is rare and there's few cellular towers around. So in this next picture I'll show you Okay, in this next picture, you can see that even though there's this full autonomous tractor here on the right, which is the red one, on the other side is a New Holland, which is still made by Case IH. There's no driver, so even now they're putting computers in these tractors where they can go full autonomous without a driver, or a driver can get back in and everything, and can run it like a normal tractor. The problems with these, which is also the exact same problems that we have with autonomous cars, is people don't really trust them. Farmers don't trust tractors, people don't trust cars. This is new technology and people are afraid of it. They're afraid of giving up control to these machines. And a lot of things, like these tractors, another issue is they're too large for road travel. That's kind of the same with semis. What are we going to do with, for example, semis with oversized loads that are wider and heavier and require more attention than a traditional car or anything? Some of these tractors weigh close to 100,000 pounds and they travel over 30 miles an hour down the road. That's a very large mass moving at a very high speed to be trusted to a machine. So, also with these, same with the car or same with anything. I don't know if any of you guys work on your own vehicles, but I personally do all my own work. So, if something breaks out in the middle of the field or in the car or whatever, there's no driver to fix it. So if something happens, you're just going to get a text sent to you and you're going to have to stop what you're doing and drive out there and deal with it. These are much larger than their automobile counterparts, so everything from there is going to have to get shrunk down into a vehicle, which could be a problem. And like I said, why do we care about tractors? Because everything that happens there is eventually going to get transferred over to the automobile industry. There's a very linear relationship between the two and their technology. So some disadvantages with the autonomous car. Insider.com states one of these vehicles, just a standard low-level entry vehicle, is going to cost around $100,000. That's very expensive, especially for the regular everyday consumer. My car doesn't even cost close to $100,000. None of my families do either. So what about who's to blame? So now that a computer's driving, is it my fault? Is it your fault? Or is it the computer's fault? Is it Ford's fault that made the car, or whose fault is it? So there's a line that's going to have to be drawn at some point in the sand for this, and nobody's really taken any steps to do it because there's not really too many of them out there at this time. Also, for civil engineers moving forward, we're going to have to redesign the road structure because a lot of people expect that these cars will be electric. So we're going to have to change for charging stations and maybe put charging stations in the road, like whenever you set your phone down and it charges. Maybe we'll have to totally redesign the infrastructure of the United States to handle these new type of cars. However, there are many advantages to this. So, also, still in Insiders.com stated the disadvantages. Now they're going to state the advantages. Roads will be safer because there's no reaction time. If something jumps out into the road and it takes humans, average of 1.5 seconds according to ODOT for their brain to click that they need to start braking, whereas a computer, as soon as the sensor trips, it can do it instantaneous. Traffic and fuel efficiently will greatly improve. All the cars will be able to talk to each other so that they can move and flow together, as well as they can decrease the amount of distance in between vehicles because their reaction time is quicker, so they can pack more vehicles on the same highway. Commuters will have more free time. We'll be able to work on homework or work things or take a nap or watch a movie or do whatever we want while our car is driving ourselves to work. So that'll help productivity immensely. Like I said, the increased highway capacity, more cars on the highway. Also, improved mobility for children, elderly, and the disabled. So now, instead of being trapped in a nursing home or in the hospital or at home, Mom can strap a little Jimmy in the car and send the car on their way and drop them off at school, and the car will come right back. Or if Auntie Jen, who's in the nursing home, wants to come visit, people can help her get in the car, and they can send the car off, and it can come visit me at my house, and then the car can go right back. And higher speed limits. Since all the braking are instantaneous, the cars can travel faster because the computer's driving it and can handle the stopping distance better. So legislature that's in place right now for us. According to Ariane Marshall at Wire.com, by the end of the year, the Congress, Congress wants to have the AV START Act in, which is the American Vision for Safer Transportation Through Advancement in Revolutionary Technologies. So this is pretty much just strengthening the laws that we have in place for traditional cars and slapping autonomous cars in front of the vehicles. So 36 states already have a patchwork of different laws saying you can test these cars or you can't test these cars, or different speed limits or whatever that they want. So the Globe and Mail website states, okay, well, so instead of legislature, we're going to move on to moral issues. So the Globe and Mail website states that the programming is not ready for this. So to do this, these cars are going to have to be able to react to any situation. That's from a little rabbit stepping out in front of the car to somebody getting pushed out into the street, or a car cutting you off, or all sorts of things. So the programming is not really ready. The technology's here, but the computer to run it is not here and not ready to be used. It's not a cost-effective solution right now. The AI is not ready to handle the responsibility. I'm not comfortable putting my brother or sister in this car and sending it on its way. I think the safest hands are still my own as far as driving goes. And some society issues. These are some issues that I think and I have problems with as far as the autonomous cars. So people enjoy driving. I love driving. It's a great stress relief for me, and I think as far as giving that up to someone, I'm not ready to do that as a human. Also, excitement at turning 16 and getting your first license, and first car. That's an excitement thing that a lot of kids go through today. Now they're just going to take that away from them, and that's a good memory for me, and I want that for my kids as well. And then what about me driving down the road and I'm still driving my car because I'm not going to buy an autonomous car, and I look over to my left and there's no one in the driver's seat? I think that would freak me out, and I think that'll freak others out. So, in conclusion, autonomous cars are not ready to take over the roads. There's still a lot of safety concerns, a lot of moral issues with these, but I think in the coming years, especially for civil engineers, we're going to be redesigning the United States interstates and county roads to be handling these autonomous cars. So as a civil engineer, we have to be open to these ideas so that we can make these changes whenever this technology is widespread and is ready to take over the roads. So with that, I'd like to conclude my presentation. If you guys have any questions, please feel free to ask.